Hey guys, we're going to go over our practice problems on page 269 today. This is our introduction to balancing equations. So in the last section we talked a lot about balanced, unbalanced, and we hadn't really gotten to balancing yet, so it didn't really make much of a difference. This section is all about balancing equations. So we're going to start with the equations they give us, right? And then we're going to have to figure out how to make it equal on both sides. All right, so we're going to want the same number of atoms of each element on the reactant side to match the product side. All right, the best way to really see this is through practice and just doing it out. Okay, so you can look on page 269 and they give you a sample problem where they do step by step by step, and so you show you essentially the same amount of steps we're going to do here. And we're just going to get started with number one. So number one, they give us P4 plus O2 yields P2O5. All right, so as you can see, I drew a little squiggly line right from our yield arrow all the way down to try and break up my reactants from my products. Okay, so that wants to be your first step whenever you're trying to balance equations, because that's what we're balancing, is reactants and products. The next thing we're going to do on either side of our squiggly line is identify the elements that are in the equation. So our two elements that we're working with here are P, phosphorus, and O, oxygen, right? So we're just going to write P and O. And it's the same thing on both sides. Okay, we only have phosphorus and oxygen. There's no other elements that we're going to try to be balancing. Okay? So that's our first step. Our second step is seeing how many we have to start. So P4, what does that mean? That means we have 4 phosphorus atoms. So I'm just going to put number 4 right next to our P on the reactant side. Over here, we have 2 oxygens, right? O2, diatomic molecule. Remember we talked about that last section. So we have 2 oxygens to start. So we just put our 2 right next to our O. We're just counting them. That's it. The next step is our product side. Same thing. Count them up. How many phosphorus atoms do we have? 2. How many oxygen atoms do we have? Look at that subscript. 5. So this is our first step. Now at the end of this, we're going to want these numbers to be the same for each atom. Right now, this is not balanced. We have 4 on here, 2 on here, 2 on here, 5 on here. Not balanced, unbalanced equation. So what we're going to do, the only key term in this section is coefficient. All right? So that's why you'll see I have these blanks in front of each of our formulas. Okay? This is where our coefficients are going to go. These are just big numbers that are going to multiply by whatever the compound is that it's in front of, okay? It does not apply to the entire reactant side. It only applies to the one formula that it's right in front of, all right? So over here on the product side, we only have one product, so it means we're only going to have one coefficient, all right? So let's get started on this. So where you want to start, I usually pick the ones that are even numbers, because we know we can multiply and figure out more easily what to multiply the even numbers by. All right, so that's how I pick. There is no right or wrong start and finishing steps as long as you have the matching coefficients or matching total numbers. Okay, so here we have 2, here we have 4. What can I do to get this 2 to become a 4? So come up here, look at your formula. All right, if I put a 2, coefficient 2, right here, that means that's going to multiply 2 times 2. I'll have 4 phosphorus atoms. It's also going to apply to the rest of that compound, and we're going to have 2 times 5 oxygens, so we're going to have 10 oxygens. So you want to make sure you're paying attention to that when you have a compound with multiple atoms, because that coefficient applies to that whole thing there. So we have 4 phosphorus because 2 times 2. So we're going to update our tally, right? And then we have 10 oxygens because it's 2 times 5. All right? So that is where we're at. We have 4 phosphorus, 4 phosphorus. Guess what? That's balanced. Check, check. Okay, we can be done with that. What's the next thing we have to balance? We have 10 oxygens here and 2 oxygens here. If we look up here, the one where we have fewer oxygens, what can I multiply 2 times to get to 10? 2 times what is 10? 5. So we're lucky that oxygen is all by itself here, so all we have to do is put the coefficient 5 right in front of O2. So this is what that looks like. 5 times 2 now. Remember, we have these things multiply by each other. So we're going to do 5 times 2 is 10. Cross out our 2. Update our tally to 10. Now we know our phosphorus atoms are balanced, and our oxygens both have 10 now. So those are balanced. And that is our final answer for balancing. All right, now number 2. All right, I'm going to rewrite it here for us. We have C3H8 plus O2 yields CO2 plus H2O. All right? All right, so notice I put those lines in front of each of our formulas in the equation because we know we're going to put our coefficients right there, okay? Next step is our squiggly line. Write down the arrow to separate our reactants from our products. All right? And we're going to put what elements we have on each side right here so we can start our tally. So we have carbon, C, hydrogen, H, and oxygen, O. I have the same thing on this side. All right? How many of each of those things do we have? All right, so take a look. Go ahead and try to fill it in yourself while I fill it in. All right, so this is what I got. The one tricky part about this when you're counting is we have oxygen in 2 spots for our products. So we have 1 oxygen here and 2 oxygens here for a total of 3 oxygens to start, okay? So that's the only tricky part about the counting for this specific problem, okay? Now let's take a look at how we can start balancing, all right? So again, I like to start with our evens. So the only element that has 2 even numbers are the hydrogens. So I'm going to go over here because this one only has 2, and I'm going to try to get it to 8. If I look up here, what can I multiply this H2O by, aka what can I put in for my coefficient to get 2 to turn into 8? 2 times what is 8? 4. So I'll put my 4 in front of my H2O. 4 times 2 is 8. And then we have to pay attention. Remember, just like the last one, 4 applies to that H. It also applies to this O. So that means we have 4 oxygens over here and the 2 oxygens that are here. So our new count for oxygen is going to be 4 plus 2 is 6. Okay? All right. So the next one I'm going to try to tackle, now that our hydrogens are happy, is this carbon up here, all right? So we have 1 carbon here and 3 carbons here. So what can I put in front of CO2 to get 3 carbons, all right? Because we want it to match up. So 1 times what gives you 3? 3. And again, look what happened. We have oxygen in this formula, or this compound as well. So now we have 3 carbons, cool, now they balanced. And now we have 3 times our 2 oxygens, because this is O2. So 3 times 2 is 6, plus our 4 oxygens over here. So 6 plus 4 is 10. All right, so now let's go through and check before we do anything else, right? We have 3 carbons, happy, happy. We have 8 hydrogens, cool. Down here we have 10 oxygens and 2 oxygens. Again, we lucked out because oxygen is all by itself over here, and thankfully it is oxygen 2, so it's a even number already. What can I do? 2 times what can give us 10? What coefficient's going to go here? 5. As soon as we put that 5 coefficient in front of the O2, we have a balanced formula, balanced equation. So we have, I'll try to get this backwards. Ooh, that's ugly. So we have 10 and 10, all right? So now we have all this balanced up. The last thing I want to do, since this one is a little bit more complicated, we have 3 elements to balance. We just want to double check our math, right? So go through here. We have C3. Any other carbons on our reactant side? No. We have 3 carbons? Cool. We have H8. Any other H's? No. 8. Cool. And then we have 5 times 2 is 10 oxygens. Any other oxygens to count up? Cool. All right, over here we have 3 times our 1 carbon. So we have 3 carbons, great. We have our 4 times 2 hydrogens. That's 8 hydrogens, great. Now our oxygens require us to count up on both formulas. 3 times 2 is 6 over here, 6 oxygens. And then don't forget over here we have our 4 oxygens. There's only 1 oxygen here, so 4 times 1 is 4. 6 plus 4 is 10. So that one checks out. Now I'm going to leave number 3 for you to do on your own, because I think if you can really tackle number 1 and number 2, then you can handle number 3 on your own. Number 4, I do want to go over part of it because it does give us a word equation. So the word equation they give us is silicon reacts with carbon dioxide to form silicon carbide, SiC, and silicon dioxide. All right, so that is a word equation that we should be used to from section 1. If we break down that word equation into a formula equation, we can make it just as easy as the other equations that we've seen. So we have silicon reacts with. Reacts with means plus. So we're going to write Si is silicon plus carbon dioxide, CO2, forgot my lines in front for a coefficient, wouldn't have enough room. The next thing says to form, that means that we're going to have our yield arrow, silicon carbide, and they tell us silicon carbide is SiC, helping us out a little bit. And silicon dioxide. So silicon dioxide means we have 1 silicon and 2 oxygens, so it's going to be SiO2. All right? If you have any questions about how we got from that word equation to this, please just message me on Google Classroom, and we can schedule a Zoom meeting with the class to really go over this step by step. All right? Next step, right? You just want to make sure that you draw your squiggles under your arrow to separate your reactants from your products. And then you want to identify your elements. We have silicon, we have carbon, and we have oxygen on both sides. All right? And we have silicon in 2 of the compounds for our products. So you want to pay attention when you're counting those up. All right, so I want you guys to try and do number 3 and number 4 on your own. If you have any other questions about anything, please just let me know, and we can continue going over this. See ya.